Today we're working on the review to get ready for the Unit 5A test. The Unit 5A test covers material from sections 11.1 to 12.3. So those are the notes that you're going to want to be studying to get ready for this test. Question number 1 asks us, for which system of equations is the solution x equals 3, y equals -1, and then there's two choices. Because it says for which, this is a multiple choice question, so you're picking either A or B as your answer. It's a little bit snug to do your room in this spot right here, so we're going to slide over to a piece of paper. In order for this point, 3, -1, to be a solution in this equation or in this system of equations or this system of equations, it would have to work in this equation and this equation. And then down here, it would have to work in this equation and this equation. Because it says for which of them, we know it's only going to be one, but we'll have to check both of them. So again, the point that you're checking is x equals 3 and y equals -1. So what I'm going to do over here is I'm going to plug in a 3 for my x, and then I'll plug in a -1 for my y, and I'll start by checking the first equation. 5 times 3 is 15. 15 minus 3 equals 12, and so I get 12 equals 12. That means that 3, -1 is a point on this line, but now I need to check and see if it's on this line as well. So I'll do the same thing here. I'll plug in 3 for my x, and I'll plug in -1 for my y. And so for this one, I'll get 6 equals 6, which means that the point also works in that equation, which means that A is going to be a system of equations that the point works as an answer to. I'm also going to do the work and check and show that it's not an answer to this one. So for this one, I'm still plugging in -1 for my y, and then I'm still plugging in 3 for my x. And so on this one, I'll get -1 equals +4 when I plug in the x and the y. And so that's not true. You actually don't have to do the work for this one. You don't have to show the work for this problem because it didn't work in this first equation, which means it doesn't matter whether it works in the second one. The answer to the question is no. It means that the point 3, -1 is a solution, or the solution for this system of equations, and it means down here that 3, -1 is not a solution for the second system of equations. Question number 2 on the review gives you two problems. This one's not multiple choice. It says the lines are graphed below. Name the solution to the system. So you'll want to remember that the solution to the system is the point where the two lines cross. On this one, the graph is scaled a little bit differently though. So this is 0, this is -4, so they're counting by 2's here. So the coordinates for this point, let's check this way too. They're also counting by 2's this way. The coordinates for that point are going to be -6, +2. It looks like -3, +1, but remember they're counting by 2's, so everything would be doubled. So this would be the solution to this system. Over here on B, these two lines are parallel, so they never intersect. And anytime that happens, we say that the answer to the question is that those lines have no solution. On question number 3, the directions say to solve the systems by graphing. It's helpful to notice that on both of these systems, the y is all by itself, the y is all by itself, the y is all by itself, and the y is all by itself. And that's helpful because these are both ready to graph. And then the same on the second one, these are both ready to graph. If one of these had a y not all by itself, it would mean that it wasn't ready to graph, and you would need to do some work to start by getting the y all by itself. But on this problem, both of them are ready to graph on both of the equations, so we're just ready to start graphing. When we do our work for the first one, so we're going to start at -6, 1, 2, 3, 4, 5, 6. And then my slope from there is 1/4, so I'm going to count up 1 and 4 to the right, and then I'll count up 1. And there's not space to put another spot on that graph, so those are the only 2 points I can fit on that one. I can draw the line for this graph, or for this line, if I'd like to right here. Oh, I guess I could go down 1 and 4 to the left, so that's a third point that would be on that line. I recommend drawing the line that goes through the points now, before you put the points on the graph, to find the other equation of the line. So the other one starts at +3, and then my slope says I'm going down 2 over 1, down 2 over 1. So I'll go down 2 and 1 to the right, I'll go down 2 and 1 to the right. It looks like I'm going to hit this point, but I want to make sure that I really am. Down 2 and 1 to the right, and down 2 and 1 to the right. And then that is, in fact, where the 2 lines cross. I could also go up 2 and 1 to the left to finish graphing the line if I find that that would be helpful for me, but this is the point where they cross. The directions to this question say to solve the system by graphing. So you're not just going to graph it and find the point where the 2 lines cross. Once you've graphed them, you have to say what this point is. So 1, 2, 3, 4, and then 1, 2, 3, 4, 5. So the point where these 2 lines cross is the point 4, comma, -5. That would be your answer to that question. On B, this line starts at +2, and then my slope is -1/3. So negative means I go down, and then I'm going to go 3 to the right, down, and 3 to the right. And I can also go up and 3 to the left, and up and 3 to the left if I want to continue the pattern for that line. It's helpful to put points all the way across your graph too, so don't just stop the points once you draw 2 or 3 of them. Put all the points on the graph because that'll help you find the point where the second line comes across and hits it. For this one starts at -4, and then my slope is -4/3. So from here, I'm going to go down 4. Well, I can't go down 4, but I would go down 4 and 3 to the right. So I'm going to go up 4 and 3 to the left. So that point would go right here. And then I'll go up 4, and then I'll go 3 to the left. And so that's the point where these 2 lines are going to cross. When you're graphing, if one of your lines you graph the wrong slope, like instead of graphing -4/3 here, if I had graphed it as +4/3, I would have potentially found a different answer to the questions. You want to make sure you go really slowly when you graph these. Your answer to the question is the point where the 2 lines cross. So 1, 2, 3, 4, 5, 6, -6, and then 1, 2, 3, 4. So for this one, the 2 lines would cross at the point -6, comma, +4. You might be able to fit your work for question number 4 into this space right here. For me, it was going to be a little bit snug, so I'm going to slide over and do my work for that on a separate piece of paper. So here's the problem written down for 4a. For 4a, you have y equals 2x minus 8, and you have y equals x plus 6. So to solve this using substitution, I'm substituting one into the other. But anytime they both start by y equals, what you're pretty much doing is you're setting them equal to each other. So if I want to find the point where these 2 lines are equal, I'm going to start by setting them equal to each other and going through and solving for x. So I'll subtract the x from both sides. I'll add the 8 to both sides. And so I'll get x equals 14. That means that the answer to this question, switching back to the other page, is going to be 14 comma something. And so now I just need to do the work to find the other number that goes with the answer to the question. So I can take the 14 and I can plug it into either one of these 2 equations. I'll just plug it into the first one. So 2 times 14 minus 8, that gives me 28 minus 8. And 28 minus 8 would give me 20. So the point where these 2 lines would cross in this first example on question 3 would be the point 14 comma 20. So 14 comma 20 would be my answer for that question. For B, I'm going to do my work a little bit differently. And depending on how your teacher taught you substitution, this might not match the work that you did on your page or that you did in your notes, but it's just a different way of thinking about substitution. Whenever I see the word substitution, I know I'm going to set up my t-table, and I'm going to write one equation over here on the left, and it doesn't matter which one you write down over here on the left, and then I'll write my second equation over here on the right. The next thing I need to do is I need to look at the numbers that are in my problem, and I need to see where there's a letter, a variable that's all by itself. So for this one, the variable that's all by itself is that first letter y. So y is going to be equal to -3x plus 14. So that means that -3x plus 14 can come over here to this equation, and it can sub into the equation for the letter y. So the 2 stays 2, the x stays x, the minus stays minus, the 6 stays 6, and then -3x plus 14 gets substituted in, the equal stays equals, and the -24 stays -24. So when you do substitution, you want to check and make sure that this matches, this matches, this matches, this matches. The equal sign matches and the -24 matches. The only thing that changed was the y came out, and this is going to go in for the y, and that's what I did right here. Now I have an equation that just has one variable, and so I can finish solving this, and so I'll do that here. I'll distribute my -6, so that's going to give me plus 18x minus 84. I'll combine like terms over here on the left. So that gives me 20x. And then I'll add the 84 to both sides. You want to make sure that before the test, you get enough practice going through and actually solving questions from start to finish and doing these steps. Because at this point, the solving part is something that you should feel comfortable with doing, but it takes a little while to get good at that. For question B, I got x equals 3, so that means they're going to cross at 3 comma something. And then to figure out the number that goes with the 3, I could plug it into this equation, but I have this space right here, so I'm just going to come over here and I'll plug it in over here. 3 times negative 3 gives me negative 9, and then negative 9 plus 14 gives me positive 5. And so that means that these two lines are going to cross at the point 3 comma 5. That's going to be the solution to the system. So 3 comma 5 would be the solution to the system for that one. Question number 5 asks you to solve each system using elimination. It's actually helpful for me to point out here that elimination is a different method than substitution was. And so when you're doing your work for these questions today for A, B, and C on elimination, you want to make sure you switch and use the other method. Elimination is the one where you look for opposites, because opposites cross out. And so make sure that as you're doing these, you're looking for opposites or you're creating opposites. In example A, for number 5, you already have opposites. This one has a negative 4y and this one has a positive 4y. Notice how on both of these, the x's come first, the y's come second, the equal signs come third, and then the numbers come last. And so that's helpful. Opposites cross out, and then the elimination method says that you add up what's left over. 2x plus 3x gives me 5x. Negative 10 plus 5 gives me negative 5. And then I'm solving for x, so I would divide both sides by 5, and I would get x equals negative 1. Once you have x equals negative 1, you can plug it into either one of these original equations, but you're going to plug it in, you're going to uncross off the y when you plug it in. It doesn't matter which of the two equations you plug it into. I'll plug it into the second one. So 3 times negative 1 plus 4y equals 5. And so then I'll add the 3 to both sides. Divide both sides by 4. And so I'm going to get y equals 2. Remember, though, the answer to this question, so the answer for number 5a, is the point where the two lines cross. So I got x equals negative 1, I got y equals 2, and so the point where these two lines cross, I'll write it right here in the middle, is going to be negative 1, comma 2. So that's the answer to the question. When you're solving them, a lot of times students will just put boxes around these two things, but you have to write it as an ordered pair because that's the point where the two lines cross. On letter B, the x's are not opposites and the y's are not opposites. So I need to multiply this one through by something to make it have opposites. And this is where you have some choice. If you wanted to, right here, you could multiply by either a negative 6 to make the x's be opposites, or you could multiply by a negative 11 to make the y's be opposites. Sometimes people will pick the smaller number, and that's what I'm going to do today, but that doesn't mean that you couldn't pick the larger number. It doesn't change the answer at all to the question. It just makes your multiplication be a little bit bigger. So on this one, I need to start by fixing that. So let's see. That's going to give me negative 6x minus 6y equals negative 24. Notice how I'm careful to multiply all of them through by negative 6. And then my second equation stays the same. In elimination, I cross off opposites, and then I add up what's left over. So for this one, I'm going to get 5y equals negative 10. And then I'll divide both sides by 5, so I'm going to get y equals negative 2. So the y value of my answer in this one is going to be negative 2, and then to solve to find the answer, I'm going to plug it into either one of these equations to figure out what x is equal to. I'll just go ahead and plug it into the first one since the numbers will be so much smaller. So x plus negative 2 is equal to 4. That's the same thing as just x minus 2 is equal to 4. And so I would add the 2 to both sides, and I would get x equals 6. The point where these two lines cross, using the elimination method, is the point 6 comma negative 2. So in our first example, we didn't have to multiply through by anything because we already had opposites. In our second example, we had to multiply one of them through by a number to make there be opposites. And then down here in our last example, it's a little bit different because these ones aren't opposites and these ones aren't opposites. And so to make there be an opposite on this one, though, I'm not going to get to just multiply one of them through by something. I'm actually going to have to multiply both of them through by something. You can either choose to get rid of the x's first, or you can choose to get rid of the y's first. It doesn't matter which one you choose. You just want to make them be opposites. So let's get rid of the y's on this one. If this is -2 and if this is +5, I need to multiply this one through by a +5, and I need to multiply this one through by a +2. Notice how since both of these, or since the y's were already opposite signs, I don't need to give either one of them a negative, because when I do the distributive property here, it's going to make this be a -10. And then when I do the distributive property here, it's going to make this be a +10. So the negative here and the positive here meant that I only had to multiply to change the numbers out front, or to change the coefficients. I didn't actually have to change the numbers that were on the inside. Excuse me, the sign of the number. This is going to give me 25x minus 10y is equal to 55. I'm really careful when I do the distributive property to make sure that I get all of them. And then this one's going to be 6x plus 10y is equal to 38. Elimination says that as soon as you make opposites, you add them up, the opposites cross off, and then you add up what's left over. So 31x is equal to 93. And then to finish, I'll divide both sides by 31, and so I'll get x equals 3. X equals 3 is part of my answer, but now I have to come back here, and I'll plug it into the second equation, since it doesn't matter which equation I plug it into. So 3 times 3 is 9. I'll minus the 9 from both sides, and then I'll finish by dividing both sides by 5. So I'll get y equals 2. And my answer for this one, or the point where the two lines cross, is going to be the point 3, +2. On the back of the review, we get into some problems that are asking us to solve word problems that have to do with systems, like this first one here. It says the sum of two numbers is 28. So that means the first number that I don't know plus the second number that I don't know. Sum means add, so when you add them up, you get 28 for your answer. So that's one equation that I can make. It says the sum of 6 times the first number, so 6x, and 3 times the second number, so 3y, is equal to 105. And so this one also had the word sum in it, which is how I need to put addition here. This is the system of equations that I'm solving. I could do substitution, and if I wanted to, that would be plenty fine, and I could do substitution. But it's kind of set up for elimination. The x's are first, the y's are second, the equal signs, and then you have the numbers over here on the end. So I'm going to choose to multiply this one through, and I'm going to multiply it by a number that's going to make either the x's or the y's be opposites. The directions to the question do say I have to find both of the numbers, so it doesn't matter which one I cross out first, because I'm going to have to go back and plug it in to get the other one too. I'll multiply this one through by, let's see, I'll do a -3. It doesn't matter which one you multiply by. I'm choosing to multiply it by a -3 because that's going to turn the 3y into -3y. Let's see, -3 times 28 gives me -84. So that's what my first equation turns into, and then my second equation stays the same. Again, the reason why I chose to multiply it by a -3 is because I already had a +3 here, so now my y's cancel with each other. This is going to give me 3x is equal to, let's see, -84 plus 105. You're going to minus them, so it'll give you 21. And then you'll finish by dividing both sides by 3, a little bit squished here, so I'm going to get x equals 7. So one of the numbers is the number 7, and then to finish answering the question, you can plug the 7 either into this problem or to this problem. I usually plug it into the one that has the smaller numbers. So 7 plus y is equal to 28. So y would be equal to 21, so that would be your second number. So the two numbers are the number 7 and the number 21. And so those would be the two numbers. When you finish solving a question like this, it doesn't hurt if you have time to go back and try to see if it makes sense. When you add the two numbers up, you get 28. And so 7 plus 21 gives you 28, so that's good that that works. And then it says that if you do 6 times the first one, so that would give you 42. And then if you do 3 times the second one, so that would give you 63. It says it adds up to give you 105. And 42 plus 63 does give you 105. So it works for both of them, and so that's how you know that that's the correct answer to the question. Question 7, A, B, and C all expect you to be able to write a system of equations to solve the problem. Kyle's family bought 4 adult tickets and 2 student tickets to the school play, and it cost them, let's see, $52 altogether. Maria's family bought 3 adult tickets and 5 student tickets, and it cost her family $60 altogether. And so you're not just solving this to solve it. You're not just solving it any old way you want to. The expectation for this problem is that you solve it using a system of equations. I'm going to have to multiply both of these equations through by something to make it cancel out. And it doesn't matter whether you want to get rid of the a's first or whether you want to get rid of the s's first. It's the same thing. If you wanted to get rid of the a's first, you'd multiply one of them by -3 and one of them by +4, or +3 and -4. In order to get rid of the s's, I'm going to multiply one of them through by, this one I'm going to multiply by 5. That would make this turn into a +10. And so I want this one to turn into a -10, so I'm going to multiply it through by -2. And so I'll distribute here, and then I'll distribute here. And I have to be really careful with my multiplication when I do the distributive property. This one's going to turn into 20a plus 10s is equal to, and then 5 times 52 gives me 260. And then this one's going to give me -6a minus 10s is equal to -120. So you do want to be careful with your pluses and your minuses when you're solving these. The 10s and the -10s are opposites, so they cross out with each other. And so I'm left over with 14a is equal to 140. And I would divide both sides by 14, and I would get a equals 10. Something that I didn't say when I started this question was the directions to the question say how much does each type of ticket cost. So it doesn't matter which one I cross out first and which one I solve for first, because they do want me to find both of them. To find out how many student tickets the family, what the cost of the student tickets were, I would plug in the 10 for my a, and I can plug it into either equation. It doesn't matter which one I plug it into. And then I'm going to go through and I'll solve it to figure out what s is equal to. So when I divide both sides by 2, I'll get s equals 6. This isn't how many tickets they bought. This is how much each ticket cost. So adult tickets cost $10, and then student tickets cost $6. And so this is your answer to the question. On problem B, the student store is selling shirts for $15 and hats for $20. So $15 for the shirts plus $20 for the hats. Trinidad bought a total of 8 items and he spent $130. The 130 has to go here because they're talking about money in this problem. If he bought 8 items, S plus H would have to equal 8. So let's make a distinction on this one before we move on. This is how much money the shirts cost. This is how much money the hats cost. And this is how much money he spent altogether. This is how many shirts he bought. This is how many hats he bought. And altogether he bought 8. So it's good to see where those numbers come from. I think that this problem is also set up to do elimination. It wants to know how many shirts and hats he bought. So I have to solve for both of them again. I'm going to multiply this one through by -15. But if you wanted to, you could also multiply it through by -20. You would get the same answer to the question. So 15s plus 20h equals 130. This equation doesn't change. And then my second equation turns into -15s minus 15h is equal to, and then 15 times 8 gives me -120. It's elimination, so the opposites cross off. Divide both sides by 5, and so it's a little bit squished, but you're going to get h equals 2. And so he bought 2 hats, and so then I'm going to go back and plug it into this equation from before I multiplied it by -15. So s plus 2 equals 8, minus the 2 from both sides, and so you'll get s equals 6. So he bought 2 hats, and he bought 6 shirts. And so that combination would give him the total of 8 items, which is easy to check. And then if you did $15 times the number of shirts plus $20 times the number of hats, it would equal $130. And so that's how you can check to make sure that it's correct. The last question on the word problem says, a jar filled with only nickels and dimes contains a total of 73 coins. So there's nickels and there's dimes, and it says that altogether there's 73 coins. So this is talking about how many of each coin there are. The next part says the value of all the coins in the jar is $4.70. So the nickels plus the dimes equals $4.70. So this is your system of equations. When you solve this one, there's also several different ways that you can do it. Notice, however, that the directions to this question tell you that you're just solving to figure out nickels. If you're solving to figure out nickels, highlight that, that means that you want to cross off dimes. So you want to multiply by something that's going to make the D cross off in this problem. So when I multiply, normally I could multiply by negative 0.5 or I could multiply by negative 0.10. But on this one, I'm going to multiply by negative 0.10 because I want to cross off dimes to do as little work as I need to do. Negative 0.10n minus 0.10d is equal to negative 7.3. And then my other equation will stay the same. Elimination says that you cross off opposites and then you add up what's left over. And so for this one, I'm going to get negative 0 or negative 0.05n when I add up those two numbers is equal to, and then for these ones I'm going to minus them. So I'll get negative 2.6 or negative 2.60 when I subtract those. And then on my calculator, I'll do the division to solve to get the answer to the question. And so when I divide those numbers, negative divided by negative is a positive, and then I'm doing the division on the other side, and so I get the number 52. I don't have to plug it in because they only wanted me to find nickels, and so I'm finished. There's 52 nickels. If you did this question differently and you solved for dimes first, that's fine. You can solve for dimes first, but you would just want to notice that you would need to plug it back in to solve for nickels, and then for your answer for this one, you would just give the answer for nickels. Question number 8 asks us to solve the systems of inequality by graphing. Notice that both of these start with y equals, and so that's good to begin by noticing because it means that both of them are ready to graph. This one says greater than or equal to. This one says less than. And so you do want to make a couple of notes about these two problems. This one's going to have a solid line, and it's going to be shaded up from the line. This one is going to have a dashed line, and it's going to be shaded down from the line. So I'll start at negative 4, and then my slope for this one says negative 1/2. So I'll go down 1 over 2, down 1 over 2, and then I'll do opposite to put a couple extra points on the graph. So for this first graph right here, it's a solid line because it said greater than or equal to. And so from this line, I'm shading up. Now when I shade up from this line, I shade it kind of lightly. I'll make sure I shade it dark enough so that you can see it in the video, but it's being shaded this direction. My second line says y is less than x plus 1. So I'll start at positive 1. And then I'm pretending like this other part of the graph doesn't exist. It's like I'm just starting over. From here, my slope is up 1, 1 to the right, up 1, 1 to the right. So my slope would go this way. And then I would also go down 1 and to the left. It doesn't matter where these two lines cross because that's not what you're trying to find. When I graph this line, it has to have a dashed line. And so when I draw it, it has to look dashed. So I'm going to be really intentional about picking my pencil up and putting my pencil down and making sure that it doesn't look like I'm playing connect the dots. My line that I draw has to look dashed. This line, it's less than this line, so it's shaded down from this line. So from ignoring all the other stuff, just looking at the dashed line, I'm shading down from this line. The answer to the question is the part of the graph where the two shading parts overlapped. So you shaded up from this line, and then you shaded down from this line. So over here, this is the part of the graph that you go back to, and you color it in to be a little bit darker to show that this is where the answer to the question is. So all of the solutions to the system would be points that are in this part over here. On question number 9, both of the lines are already graphed for you. So both of them have already been placed on the graph. On this one, the y is all by itself, and on this one, the y is all by itself, which means we should be able to match up which one's which. This one says greater than or equal to, and so this one would be a solid line, and it would be shaded up from that line. This one says less than or equal to, so this one would also be a solid line, but it would be shaded down from that line. In order to figure out which line is which, we have to look at the slope. This one has a positive slope, which means the line is the line that's going up, and this one has a negative slope, which means the line is the line that's going down. So the one that has a positive slope is this line right here. I'm going to go ahead and color code these so that it's easier for you to see which one's which. So this 3/2 x plus 3 1 is this line right here. The color doesn't mean anything, by the way. It's just so that you can tell which one's which. So from that line, it says greater than or equal to. So I'm going to shade up from this line. So I would be shading this way. And then my second line has a negative slope, so that's this line over here that we're talking about. And that would be this line over here, y is less than or equal to negative 1/2 x plus 5. And from that line, it says that you're shading, let's see, down from that line. So you would shade this way, below the pink line. And then your answer to the question is the part of the graph where the two shaded parts overlap. So you go back when you're finished, and you make this part of your graph be extra dark, because that's the part of the graph where the two shaded parts overlapped. And so any solutions to this system would be points that are here in this part that's shaded in the most dark. The last question on the review wants us to graph the system of inequality shown below and then name the points, if any, that are solutions to the system. Notice that on both of these, the y is already all by itself, which means that they're ready to graph. The lines are missing from this picture, so we need to draw the lines onto the picture. This says greater than or equal to, so it's going to be a solid line, and then you're going to be shading up or above the line. This one is going to be a dashed line when you graph it, and then you're going to be shading down or below the line. So it's good to make notes about that so that you can practice putting the correct line on your graph. So I'm going to ignore all the points on the graph for just a minute, and I need to go through and graph these two lines. For the first one, I'm going to start at positive 3, and I'm ignoring all the points that are on the graph. And from there, my slope is 1/2. So I'm going to count 1/2, up 1/2, up 1/2, up 1/2, and then I'll go down 1/2. Remember, slope is always up and to the right or down and to the right. So when you're graphing slope, you want to make sure that you follow that pattern. This one, I already said the line was going to be a solid line, and so I'll draw the solid line on there. And then the directions to the question for this one said that it was greater than. So from that point, from that line right there, I'm shading above the line. So I'm going to shade up. And so I would be shading in this direction. A, B, and D can't be answers to the question yet, though, because I haven't shaded the second line to see where the location for the second line is. So that's what I need to do next. This one starts at -4. And then my slope for this one is down 1 and 1 to the right, down 1 and 1 to the right, down 1 and 1 to the right. And then I can also go up 1 and 1 to the left, and I can follow my slope that way. It doesn't matter that the two lines don't cross at a perfect point, because that's not what we're looking for. When you draw this graph in, though, make sure that when you draw your line on the graph, it needs to look dashed. So I usually just pick my pencil up and put my pencil down, and I try not to connect the dots, because sometimes when you connect the dots, it looks like it's a solid line. So for this line, I'm shading down or I'm shading below the line. And so, oops, just kidding. I actually wrote the wrong direction on this one. So this one's supposed to be shaded up or above the line. So, because it says greater than right here. So if it's dashed and you're shading up or above the line, you'd be shading this way from the dashed line. You're going to be shading up above it. And so it would be shaded in this direction. Right here. And then the answers to the question is the dark part where the two shaded regions overlapped. So for this one, you shaded above both lines. And so it gives you this part of the graph right here. So that's the part where the graph where it's shaded in dark. When you decide that this is your answer to the question, so this is the part that's shaded dark, it says what points are in the solution set, if any. So we can all agree that A is for sure in the solution set because A is in the shaded part. So you would list off A as one of your points. That's an answer to this question. But here's where it gets a little bit tricky. There's only one other point that's in the solution set to this one. When you look at your graph and you see where B was originally located, B was this point right here. It was the point that they had written, not the point that we drew. B is on a solid line, and so B is also going to be an answer to the question. The reason why you include B is because it's on a solid boundary line. A was in the shaded part, or in the shaded region of the graph. It is important for you to note, though, that if B wasn't on a solid line, like a point F right here, I know it's not in the right spot, but if it was on a dashed line, points on a dashed line are not included, but points on a solid line are included. And so that's why you would keep B as an answer to this question. So it's anything that's inside this dark shaded part and any points that find themselves on a solid boundary line. If you have a point that's on a dashed boundary line, you would not include it in the solution set.